We have two square roots of quadratic polynomials to find the maxima of their difference and the minima of their sum. I'm going to present two methods. Geometry methods. The square roots represent distances between points. This can be seen by completing the squares. And an algebra method. I'm going to convert the problem into inequalities derived by discriminant of quadratic equations. First, the geometry method. By completing the square, the quadratic polynomial in the first square root is separated into two parts. 34 equals 25 plus 9. We end up with a sum of two squares, square roots of x minus 5 squared plus 0 minus 3 squares. This is the distance between two points, point P with coordinates x0 and point A with coordinate 5, 3. Similarly, the second square root is also a distance. It is between P and another point B, 2, 1. We have 3 points here. A and B are fixed points. P is an arbitrary point on x-axis. In this graph, the first square root is the length of the segment PA, the second one is PB. We need to find the maximum of PA minus PB and the minimum of PA plus PB. First, let's look at the maximum of their difference. If PA and B form a triangle, then by triangle inequality, PA minus PB cannot exceed the length of the third side, AB. So, AB is an upper bound of the difference PA minus PB. The upper bound can be assumed when PA and B are collinear. In this case, PA minus PB equals AB. Therefore, the maximum of the difference is the distance between A and B, which is the square root of 13. Now, let's consider the minimum of PA plus PB. Let B prime be the reflection of point B about x-axis. Then PB equals PB prime. And the sum of PA and PB becomes PA plus PB prime. So our new goal becomes to minimize PA plus PB prime. Again, by triangle inequality, PA plus PB prime is greater than AB prime if these 3 points form a triangle. So, the sum has a lower bound, AB prime. On the other hand, the lower bound can be assumed when PA and B prime are collinear. So, the minimum of PA plus PB is the distance between A and B prime, which is 5. Algebra methods. Let A be the first square root and B the second one, and denote their sum as T. We want to find the minimum of T. We have A squared minus B squared is the difference of two quadratic polynomials, which equals -6 plus 29. Because a squared minus b squared is a plus b times a minus b, and a plus b is t. We have t times a minus b equals negative 6 plus 29. Therefore, a minus b equals negative 6 plus 29 divided by t. So we have a plus b equals t and a minus b equals negative 6x plus 29 divided by t. Sum up and clean up. We have 2at equals t squared minus 6x plus 29. We know by definition a is the square root of a quadratic polynomial in X. We do a substitution and square both sides. We establish a rational relation between t and x. We expand and combine like terms by x. We establish a quadratic equation in X, and we know X is a real number. Because the quadratic equation has real roots for X, its discriminant must be non-negative. B squared minus 4ac is greater than or equal to 0 by definition. Simplified, we got only 3 terms. We can further factor it. We have 3 vectors, t squared minus 13, and t squared minus 29. The product of the 3 vectors is greater than or equal to 0. By the definition of t, which is the square root of a quadratic polynomial plus another square root of a quadratic polynomial, which is clearly greater than or equal to 4. Therefore, the first and the second factors are both positive. So, the third factor, t squared minus 25, must be non-negative, which means the minimum of t is 5, because t is positive. Thank you for watching the video. Please consider subscription of the channel. I appreciate your support.